Hello everyone, this is Vashishtha from AEROSPACE section. I am going to explain about structural optimization of truss using finite element analysis. So, structural optimization of truss. What is a truss? So, a truss is an assembly of members such as beams connected by nodes that creates a rigid structure. As we can see, the nomenclature of a wing, it has airfoils. So the truss of a wing is an airfoil. Airfoils, in coming to an airfoil, in airfoil we have different types of trusses, and there are different types of nomenclature which can be done in the trusses. So using finite element analysis, it's a software in which use it for structural optimization to get better results of a structure. So, coming to the introduction of our topic, optimization of steel structures has a wide scope in structural engineering. Due to their own complication, reliability of results and its advantages to the industry. Weight optimization of truss structure plays a vital role in economic and sustainability considerations. The analysis part and the optimization process is very complex and less reliable for manual calculations. Hence, nowadays, high performance computing systems such as programming language or pre-programmed softwares is used to solve huge data of trust structure. Obtaining the desired results with accuracy, the design of truss structure is based on the result of size, topology, and geometry optimization. So the size optimization deals with the provision of minimum or cross-sectional area for members by assuming the nodes connectivity and coordinates are fixed. Topology optimization deals with the connectivity of member between nodes. Geometry optimization deals with the determination of the optimum node coordinates by assuming the topology of a truss structure is fixed. So, as we can see, these are the trusses. It's a shape in which there are structural integrates which connected by the nodes. A topology is shape and size. For types of optimization method for degrees, discrete and continuum structures. So there's a method called finite element method and Matlab. Finite element method, also known as FEM, is a numerical procedure for solving mathematical model numericals. FEM numerical. FEM uses descriptions, nodes, and elements to model the engineering system. That is, subdivided the problem system into small components or pieces called elements, and the elements are comprised of nodes. Approximations are introduced over each element to represent the behavior of the unknown variables and in finding out unknowns. Matlab is an integrated programming system, includes graphical interface and large number of specialized toolbox for mathematical operations. In analysis type problems, basic variables are unknowns and displacements. This unknowns is expressed as unknown field variables in terms of shape function. So, with the help of Matlab linear programming, the mechanical model is converted into a mathematical model, and then shape function is used for each nodal point and known as unknowns are found. So by using this both finite element method and Matlab, we can easily find out the structural truss of a given elements or given structures. And methodology, how do we do? I mean, what is the method including in this finite element methods and Matlab? In case of plain 2D trusses, the DOF available at each node is 2, which results in sometimes larger size of matrix, and it is a very complicated task to solve it manually. So in the study program is developed using finite element analysis in Matlab for analysis of plane truss. The program is able to analyze the plane truss structures with an n number of numbers and boundary conditions based on the results obtained from the program. Further optimization is carried out. It's a popular method for numerically solving differential equations arising in engineering and mathematical modeling. It can be 2D linear line elements, 2D planar elements, and 3D solid elements, which are all used to define geometry. So this is a formula regarding the methodology, including in this. With a minimum W of A and A of Li with A is equal to A1 to AN. And A minimum is less than or equal to A is of A, and for I is equal to 1 to N. Sigma minimum is less than or equal to sigma I less than or equal to sigma max. For I is equal to U minimum is less than or equal to UI less than or equal to U max. So plane truss modeling. There's an example given here. The geometrical configuration of 13 bar benchmark truss is shown in this figure. The node number, member connectivity, support conditions, and loading of truss is shown. The yield stress sigma is limited to plus or minus 250 megapascals, and displacement delta constraint is 11.1 mm for vertical displacements. So here the load is given as 60 P. Load P is given as 60 kilonewtons with the mechanical properties as area is 1000 millimeters per second square, millimeter. Modulus of elasticity is equal to 2 into 10 power 5 megapascal. F is equal to 1.1. Sigma is equal to 7850 kg per meter. So, an analysis and results of the given finite element method and Matlabs are given here. A Matlab of model of structure with first iteration. A truss structure is programmed in Matlab code with 6 nodes. Load of 60 kilonewton is applied at node 2 and 3, and node 1 and 3 are fully constrained subjects to support conditions. Matlab modeling structure. Truss structure. Here it is given in this diagram, truss structure with the x coordinates and y coordinates. And the output of FEM code, finite element method code, is given here with stress, axial force, energy, white node number, deflection. The red colored boxes indicates that the strain energy stored in the member is very less as compared to the other members. As we can see at the number of initial 3 members and 6, 7, 10, 11. Here we have red bunks and red boxes. So the strain energy stored in these initial members are less compared to others. Hence, it contributes less in load transfer mechanism, which in turn is removed from structure. So we have to remove the less strain. The energy stored members with less compared are to be removed. Sometimes the C/S area of member is also reduced so that the work done by the member is more and stores maximum energy. So the red boxes are to be removed and the points and the stresses are to be removed. Optimum result. The structure of 4-bar truss is suggested for minimal weight and optimum C/S area. It is recognized that there are 9 members in which strain energy stored is minimum in 13 bars truss structure with optimum structure of 60 kilonewtons, and it's a model of optimum truss structure. Space trusses. In case of space trusses, the DOF available at each node is 3, which results in larger size. which results in larger size of matrix and it is very complicated task to solve manually. So in the study program is developed using finite element analysis in Matlab for analysis for space truss. This program is able to analyze the space truss with n number of members and boundary conditions. Coming to the modeling part, geometrical configuration of 25 bar benchmark space trusses, the node number, member connectivity, support conditions, and loading of truss is shown. The yield stress sigma is limited for plus or minus 250 MPa and load displacement delta. And it's a given another question with load with the node 1 and load with node 2. And the material properties C by S area is 10,000 millimeter square and models of elasticity 2 meter and 5 MPa. So here we can see that the displacement of truss structures are given with the red colored boxes with strain energy less compared to other members, hence it is contribute less in load transfer mechanism, which in turn is removed from the structure. As we can see here, the 3, 5 and 6 and 10, 11, 12 are to be removed. These structures make our total truss structure weak. So we have to remove all 3, 5, 6 and 10, 11, 12, 13, 14 and 18 boxes to store the maximum energy in others. So coming to the conclusion, from the above iterations performed on the benchmark truss, reduction of small number of members and C by S area of exciting members is found to be reduced. Reduction in C by S area results in less consumption of construction material to be used, which in turn reduces the total dead weight of the structure. From the above methodology used for optimization, materials are used or stressed to full capacity, resulting in materials saved. The programming language developed can be used to solve larger complex structures with accuracy and quicker results as compared to manual methods. So this is all about my explanation on process using finite element method. Thank you.